Welcome to Homework Lib.
Hi, so for this question, we're going to have benzoic acid that I'm going to label as HB. Well, acid. And we have benzoate that I'm going to label as B minus. So the first thing that we need to do is calculate the amount of mole that we have of each of them. Why is that? If we look at our Henderson-Hasselbalch equation, you're going to see that we have a factor that looks like this. But the molarity is nothing but the amount of mole divided by the total volume. And since we are dealing with a solution, the total volume, it is going to be the same on each of them. So we can replace this Henderson-Hasselbalch equation in that factor as NB minus divided by NHB. Let me take this guy out and write it down as an N. Okay, so now the amount that I have added of HB, it is going to be equal to the volume times the molarity of my solution. And the volume needs to be in liters. Recall that molarity is N divided by volume, so N is volume times molarity. So 0.125 liters times 0.75 molar. And the amount of mole that I'm going to have of B minus, it is going to be 0.2 liters times a 0.5 molar solution. This is going to give us 0.1 mole and 0.09375 mole. Great. So we have these two amount of mole. Next up, they add 15 milliliters of a 1 molar solution of HCl. Remember that HCl in water is going to produce H2O plus Cl minus. So the amount of mole of H2O plus that I'm going to have is equal to the volume, again, in this case 15 times 10 to the minus 3 liters, times my concentration, so 1 molar. So I have 1.5 times 10 to the minus 2 mole of H2O plus. With this information, I can set up a nice table for the reaction of the acid with the base that I have present in solution. This is going to look like B minus plus H2O plus. It is going to generate HB plus water, my benzoic acid. This ice table, it is going to be in terms of mole of B minus. I have initially 0.1 mole. This is the easy one. Of H2O plus, I added 1.5 times 10 to the minus 2. And initially of HB, I'm going to have 0.09375 mole. The limiting reagent is H2O plus, so that is the species that is going to react. And here I'm going to add 1.5 times 10 to the minus 2. At equilibrium, I'm going to get 0.085, or let's do everything in scientific notation, 8.5 times 10 to the minus 2, something close to 0. And finally, 0.10875. And all of this is mole. Now, why I did the comment at the beginning that I can replace this B minus with amount of mole on B minus and HB? Because we don't need to calculate again the concentrations using the total volume. We can skip that step and go directly into our Henderson-Hasselbalch equation, because we know that pH is equal to pKa plus logarithm of concentration of B minus divided by concentration of HB. What we showed before is that this is going to be equal to pKa plus logarithm of the amount of mole of B minus divided by the amount of mole of HB. We are given the Ka for benzoic acid, that is 6.4 times 10 to the minus 5. This gives us a pKa of 4.2. Thus, our equation now becomes pH is equal pKa 4.2 plus logarithm amount of mole of B minus 8.5 times 10 to the minus 2 mole divided by amount of mole of HB. The final result is 4.093. Let's verify if the result makes sense. The pH is lower than the pKa. That it would be true if the amount of acid is more than the amount of base, which is what we have right here. And that would be all for this problem. This is the final pH of my solution. Thank you very much.